All right, here we go. We are doing the last section, like I said, and I just called it radicals. What in the world is a radical? Back in the 80s, I don't know if you remember. Well, you don't remember, but if you've ever seen old things on you, that Little Rascals, nah, that goes way beyond before the 80s. Yeah, radicals. Guys, if you let me talk, please. So we used to have the expression in the 80s if something would be really cool or wild or like crazy, we'd say, that's radical dude. We'd say radical. I didn't say it a whole lot. I probably wasn't cool enough to say it, but but for a short period of time in the 80s, people would say radical all the time, but that's not what this means, okay? A radical basically is this, okay? This is a radical. And we have stuff that goes inside the radical, right? So I'll just use a letter. The letters represent numbers, obviously. Okay, so the symbol itself, that little check mark looking symbol, that's actually called the radical. All right? It's not always a square root, okay? We always think that that's a square root. It's not always a square root. But that little check looking thing is called a radical. The thing that's inside the radical is called the radicand. Radicand. Make sure I spell it right. All right? And then you could have a thing out here. You could have like a cubed root, right? Or a fourth root. Do you remember that from Algebra 1? All right? You've had stuff like that. So that's the letter N. That's out there. And they call this the index. I probably won't refer to the radicand in the index that often, but the radical, those are just words that we use in math, just so we're on the same page on this, okay? Do I want to go through all this stuff? I think I might just go right to the example. We'll do this part first. Okay, now, if you see a radical, and I'm just going to put a number in here, and there's no number on the outside, there's no index. You see that? This number on the outside of the radical. And this index, by the way, would be small. It wouldn't be right next to it. It would be little. So if you had like the square root of 3, but it's not the square root, maybe we had a little 4 right there. That would be the fourth root of 3. Everybody see that? So it's not a big old 4. That's different than this. What is this? This is 4 times the square root of 3. This little 4, this tiny little 4 right here means something different, okay? It means the fourth root of 3. We'll talk about that here in just a second. All right, so if you do have this number up here, it's not going to be real big. It's going to be small, about half the size of a regular number. It's going to be up in the little crook of this little check mark right there, okay? But if there's no number up here, what do we call this? This would be the what of 16? The square root of 16. And what are we asking when we say the square root of 16? We're saying what number times itself, okay, is equal to 16. You follow me on that? I shouldn't put it equals right there. This is what I should do. All right, so what number times itself? Not just one number times anything else. What number times itself? The same two numbers multiplied together have to be 16. Right, so x has to be 4. So the square root of 16 is what? Is 4, right? Now, we could put a little index. What do you think the index would be if we put a little? No. How many times did we multiply x together? 2 of them. So what number times itself? Okay, so you could put a little 2 up there. Most of the time we don't, because square roots occur so often, they're so popular, that people decided, I don't even want to put the 2 there. I write it so much, let's not even put the 2. But all the other ones, you're going to have to put a little number up here. Okay, so for instance, if I said, and I put a little 3 right there. So if I put a little 3, what in the world does this mean? It doesn't mean what number just times itself, just 2 numbers that are the same numbers that equals that radicand or that thing inside of there. It's 3 numbers. What 3 numbers? And they all have to be the same. Okay, what 3 numbers, all the same, multiply together to be 27? So it would be like this. It's what number times itself times itself. So what number times itself 3 times is going to give you 27? Necia? 9 times 9 times 9 is 27? 3. Right, 3 times 3 is 9, times another 3 is 27. So when you have this little number up there, that means what number times itself 3 times is equal to this number inside the root? Everybody got it? Okay, and obviously x would be what? 3. You okay with that? All right. Okay, let me show you something else. What if I did this? Let's go back to the square root again. Okay, so what if I said, let's do another number. Let's go 25. I want you to show you something here. What number times itself is 25? You should be able to figure that out. It's 5, isn't it? Okay, so watch this. You could rewrite 25 as 5 what? Squared. Do you agree? But this is under a square root, so this has to be under a square root. Would you say the square root of 25 was? 5, okay? But we could rewrite it like this, couldn't we? And there's a reason I'm doing this. All right, so 5 squared is 25, and if I take the square root of 25, I get what? 5. So basically, what just happened here? What happened with that squared and the square root? They basically cancel each other out. Okay? I heard cancel out back there. That's why I looked back there. Do you see that? So basically, the square root of 5 squared is just equal to what? 5, because the square root cancels out with the what? With the square. Everybody see that? Okay, because they're inverses of each other. If I square something, what's the inverse of squaring something? Taking the square root of it. You with me on that? Let's do that 27 again. How could I rewrite 27? 3 to the... No. 3 to the 27th power? That would be some gigantic number. So look, what would this be? Just looking at it, without even doing 3 cubed, you should be able to look at the... I'm sorry, I lied. There we go. What if I had the cube root of 3 cubed? What happens to the cubed and the cube root? They cancel each other out, don't they? All right, so watch. That and that cancel each other out. What am I left with? Just a 3. I know there's a lot of 3s floating around here, but that's what happens. What if I had this? What if I had 17 squared? Now, do you know what 17 squared is off the top of your head? Me neither. I think it's 289. Is that right? Somebody do that. Yeah, 289. Okay, so I did know it off the top of my head, but most people don't, all right? So what if I did this, though? What would this be equal to? Without doing any math at all. You don't have to do any arithmetic. Just looking at it, I can tell you what that answer is without being super smart or anything. What is it? Why is it 17?
Because it's a square root and the squares, they cancel out.
Exactly right. This square root cancels out with this squared, so what am I left with? Just 17. So that's pretty nice, isn't it, when that happens? Let's do another one. So what if I had, I don't know, pick some crazy number.
125.
Let's go crazier than 125. 199? Okay, let's do 199. And what if I put 199 squared? Do you have any idea what 199 squared is? What? 199 squared. Listen to my question. 199 squared. 199 times 199. Can you do that in your head? All right, there you go. Could you have done that without your calculator? Well, I could have gone over here. I could have come over here and done this, right? And then I would have got some big old number. But even then, I wouldn't know the square root of that number off the top of my head. But looking at this, remember, that's got to all be inside that square root. But looking at this, I can tell you what this answer is without really doing any math at all. Because I know that square root and that square cancel each other out. So what's my answer? It's 199. With me on that? Let's do another one. Let's go more general. That's right. Okay, just looking at this, what's the answer to that? It's just x. Why? Because that square root and the squared, they cancel each other out. You with me? The same thing when you don't have square roots. What if I had 7 cubed and then the cube root of this? Exactly right. Now you're getting the hang of it. Everybody see that? So the cube root, guys, the cube root and the cube cancel each other out. What am I left with? I'm just left with 7. Everybody with me? Okay. So we're going to do some things that are more complicated, but we're starting off pretty basic. Stop whining. You're the whiningest student I've ever had. Maybe not, but what if I did this? What if I had the square root of negative 36? Everybody look up here. Let's think. Guys, here. Square root of negative 36. So what are you asking yourself when you do the square root? What number times itself, right? The same exact two numbers. If I multiply them together, I'm going to get negative 36. You got your calculator out, right? Put it in there. Do you know how to do square root on the calculator? On yours, you probably just put negative 36, then you hit the square root button. Now, if you had a graphing calculator, which I just happen to have on my, right there. Yeah. What's yours say? Yours says error, okay? So on this calculator, use this button. On this calculator, I would put the square root first, then I'd put a negative 36. If you have a scientific, let me see your calculator. If you have a calculator, well, actually, this may, it depends. If you have a Texas Instrument and it looks like this, it's real small like that. If you have a Texas Instrument calculator, for the most part, this is Casio, but if you have a Texas Instrument, then you may do this. Listen. Yeah. See gauges? If you have a calculator that looks like that, most likely, now they have changed them a little bit. Depends what model you get. But for the most part, you would put negative 36 in your calculator first, and then you would hit this. Guys, please. I'm trying to talk. So you would put negative 36 in your calculator first, and then hit the square root button. You're still going to get an error. All right? Anybody have a calculator on them? Okay, try it. Put a negative 36, hit square root, you'll probably get an error. But if you have a calculator like this, you're going to hit the square root button first. Where's the square root? It's right there. But it's not actually a button. It's behind the button. So what do we push? The second function. I can't use my pen for this. Second function. Then you hit that. See, it makes a little square root symbol. And then I'm going to put negative 36. So negative 36. I always like to close the parentheses. I don't know. I'm just kind of OCD about that. I don't think it makes any difference. But then when I hit enter, non-real answer, it says. It doesn't just say error, it says non-real answer. Because think about it. Think about it. Is there a number, if you multiply it by itself, you're going to get it negative anything? Because what happens when you multiply two negatives together? You get a positive. What happens if you multiply two positives together? You get a positive. Is there any way to multiply the same two exact numbers and get a negative answer out of it? There is no way. All right, that's why your calculator says error. So can you do this? No. Not right now anyway. Later on. I don't know if we'll do that or not. Yeah, so if you had Algebra 2, who had Algebra 2 last year? Okay. You probably did this in Algebra 2, didn't you? Okay. When you have a negative inside of a square root, that's an imaginary number. I don't know if we're going to get to that this year or not. We'll see. But no, it's not complicated. All right. Yeah, stop crying. Tired of wiping up the tears. All right, but watch this. What if you had this, though? We'll use that same number that we used before, and I said cube root. Now, this doesn't say just what two numbers multiplied by itself, what three numbers. Can you have three numbers that multiply together and get a negative answer? Three of the same numbers. Absolutely, because a negative times a negative is a positive times another negative is a negative. Okay, so can you have a cube root of a negative number? Absolutely. Okay, and what would that answer be? It'd be negative 3. Because negative 3 times negative 3 is positive 9, but times another negative 3 gives you negative 27. So just because there's a negative inside of a root or a radical, it doesn't mean that you can't do it. The problem is when you have what type of a number? Not just a square, but an even number. Anytime you have an even root, you can't have a negative inside of it, all right? Because you can't have an even number of numbers multiplied together to the same number to be negative whatever. Do you agree? But if you have an odd number out here, then you can have a negative inside of this. All right? Does that make sense? Okay, let's talk fractions. I know you love fractions. What if I gave you this?
Oh my God.
What do you think?
I know.
Go ahead.
Would it end up being 1 over 4?
Yes, why?
Because you're doing the opposite when you're dividing a fraction, so you would end up multiplying it. Kind of like.
Yeah, I'll say it this way. Let's do it this way. Here's a rule. There might even be a name for it. I don't even know what the name is. I didn't write it down or anything. But there's a rule that says if you have a fraction or something being divided inside the square root, here's what you can do. You can take the square root of the top, what do you think? And divide it by what? The square root of the bottom. Exactly. I think there's a name for it. What's that? Well, if you wanted to write the step, you could do this in your head if you wanted to, okay? But I'm just showing you what you're doing in your head, all right? So, and the same thing with multiplication. So if I had, I don't know, if I had like 4 times 3 and it was under a square root, you know what I could do with that square root? I could go square root of 4, what do you think? Times, not times 3, times the square root of 3, okay? And let's simplify this one since we're already here. What's the square root of 4? It's 2, right? And can you simplify the square root of 3? No, you just keep it the square root of 3. Everybody see that? All right, we'll get to that in a second. But that kind of deals with this. Thank you. So let's figure out what this is. Carter said the answer is 1/4. Do you agree with him? Yeah, because the square root of 1 is what? Because what number times itself is 1? 1 is. 1 times 1 is 1. Okay? What's the square root of 16? It's 4. So the square root of 1 over 16 is the same as just 1/4. These problems will say to simplify. Okay? That's what they're going to say. It's going to say simplify this. This is simplified. All right? We good with this? All right. All right, good. What if we had something that didn't come out real nice and even? What if we had this? What if I had the 5th root of 16? What does that mean? It means what number multiplied by itself, how many times? 5 times is going to give me 16. 2? 2 times 2 is 4. Times 2 is 8. Times 2 is 16. But then another one's going to give you 32. So it's not 2. All right? It's not going to work, is it? Or at least it's not going to come out even to a nice whole number. But you can do this in your calculator. All right? So let's come over here. Let's turn this back on. Went to sleep on me. Let's clear it. Let's clear that. Thank you. All right. How in the world do I do this? Wow, it's been a long time. Now I'm going to have to remember. There's a... I haven't used this calculator in 10 years, so... Which one? I can't see it. Next to the 4. No, that's not it. No, that's an e to the x. That's something different. Yeah, I know. It's hard to see up there. Mr. Rao, how do I do a 5th root on this calculator?
Oh, you go to the square root and type it 5.
Do I hit second function?
You have to make the exponent of 1/5.
Oh, so you can't actually do 5th root. Okay. All right. That's
Put the caret symbol into the exponent, then in parentheses 1/5.
okay. He is talented. All right. So, well, here I'll show you this. Since he mentioned that, everybody watch. Look. Okay, bell's about to ring, so pay attention. So the 5th root, you could write it like this. Oops. You could write 16 to the 1/5 power. So you should have a button on your calculator that looks like this, y to the x. All right? So what you would do, listen, Demir, I didn't dismiss. So what you do is you're going to put 16, listen, you're going to put 16, and then you're going to hit this button. Everybody see that button on your calculator? Okay, and then you're going to put a 1/5, and then you'll probably get something like 1.74 something. Okay? All right? And that's what the 5th root of 16 is. And it just gives you some bunch of random numbers here. Okay? That's how you do that. Well, I'm saying when you use a calculator. When you use a calculator, it doesn't have a 5th root button on the calculator, so you use this. Right. Okay? You probably won't be able to do a whole lot of the homework tonight. So look at it, see if there's anything you could do on it. We'll finish up tomorrow. Okay?